This video is going to cover the how-tos on your graphing calculator. I'm going to do the last problem from the notes on section 5.8, and I'm going to go through how to do it on the graphing calculator versus how to do it on Desmos. First thing you need to know is how to plug in. The 5 graphing calculator keys, the 5 keys that are specifically related to graphing are the 5 keys underneath the window, and they are in a creamish grayish color. Y equals, window, zoom, trace, and graph. Y equals is where you're going to plug in whatever graph it is that we're going to try and analyze. Y equals. You may have some information in your calculator. You can type right over it, or you can just clear. So if you have whatever plugged in, and you just push clear, which is underneath the arrow keys, goes away. Okay, the most important key when you're graphing is the XT, and then that's a fancy O. It stands for theta, Greek, and N. This represents the variable key. So the second problem on the notes was x to the 4th. So I'm going to push the X key, and you'll notice it shows up as an X, and then caret, which is underneath clear, so caret, and notice it brings you up to an exponent. I'm going to type the number 4, and then you need to right arrow so that you can start a new entry. Plus X, so use the X key, cubed, so I'm going to use the caret, and then 3, and then minus, so minus 4, and then again the X key. For X squared, there's actually an X squared key to the left of the 7-ish. So you can push that if you'd like. And then plus 5. And now I want to see what the graph looks like. So you have your whole Y equals plugged in. And now I want to see the graph. So I'm going to push graph. And let's see what it looks like. There it goes. It looks like a weird, I don't know, W or something. Okay. So I'm going to sketch this graph on my paper. Well, it has a couple of x-intercepts. It has a y-intercept. Let's figure out where those x-intercepts are. Okay. Second, and then trace. And you'll notice that in blue above trace, it says calc for calculate. This is going to be where we do a lot of our analysis for the graph. I'm going to be able to calculate zeros, minimums, maximums, intersections. Okay. Well, an x-intercept is the same thing as a 0. So I'm going to go down to number 2 and push enter, or you can just push the number 2. So again, let me quit second mode. Let me do that again. Second, trace, and then either arrow down to number 2 or push number 2. Okay, left bound means I need to set a boundary to the left. Where do I want the calculator to find the 0 of? So using your left arrow key, arrow somewhere above that 0 and push enter. Notice the calculator now says right bound. Arrow to the right so that you are now underneath the x-axis. Guess, push enter, and it's telling you that the 0 is at about negative 2.32. You might be a little bit off compared to me, and that's okay. So I have a 0 at about negative 2, give or take. So negative 2 or so. I already know the y-intercept of this graph is at 5. 1, 2, 3, 4, 5. Okay. Okay, there's another x-intercept. So I'm going to do that again. Second, trace, number 2. So you can either arrow down and push 2 or just push the number 2. Now I want to find the next x-intercept. So I'm arrowing, getting close. You don't have to be exactly on top of it, but somewhere below the x-axis, push enter. Above the x-axis, push enter. Guess means put your cursor like really close on top of that point that you want. Push enter, and I get negative 1.14. I know this is fuzzy. My graph says negative 1.14. Whatever, good enough. And then I'm just going to sketch the rest of this. Okay. The domain of this is all real numbers. The range. So this point right here is my lowest y value. I'm going to trace that. So I'm going to push the trace key. And I'm just going to trace and approximate what that value is. It looks like it's about negative 1.8 comma negative 3.3-ish. Okay, you may not have the exact same values, but I just pushed trace and I just arrowed close. So it looks like it's going to write it down as negative 1.8. This is a turning point. And the y value was negative 3.3. That's my lowest y value. So my range is bracket negative 3.3 up to infinity. The end behavior of this graph is up, up. So these are both infinity. Okay. I'm going to find out the actual values of this minimum and this maximum. So on the calculator, I'm going to go second, trace, and notice that one of my choices is minimum. So either arrow down to 3 or push the number 3. And again, it's going to ask me this left bound question. So I'm going to go to the left of the point somewhere, push enter. Now it says right bound. I'm going to go to the right of the point somewhere. I'm going to push enter. And then for guess, I'm going to try and use my arrow keys to get on top of that point as close as I can, push enter. And that point is, as we had determined before, negative 1.8, negative 3.3. So that is the value of my minimum. You will get better at the calculator with time. The maximum, again, I'm going to do second, trace, that accesses the calculate menu. And this time I want to do the maximum. And it's going to ask me for the left bound, right bound. So I'm going to get to the left of that maximum point, which looks like 5. The right of that maximum point, guess I'm going to get close. And it looks like when it says x is negative 1.8, e negative 6, that's pretty much 0. So my maximum is 0.5. You'll notice that there are 2 minimums. There's a turning point. The graph is decreasing till it hits that minimum, goes up, hits the maximum, increases, decreases, and then increases again. So we have another minimum. Arrow. So again, I did second trace. I want to find the minimum. Left bound, arrow and push enter. Right bound, arrow to the right and push enter. Guess, get as close to it as you can and push enter. And it looks like that minimum is at about 1, 2.95. So my graph isn't very good, but there's another point at 1, 2.95. So there's another minimum. increasing, decreasing intervals. Okay. All right. Increasing and decreasing intervals. So I'm decreasing from negative infinity and I decrease until I get to the x value of negative 1.8. And then from the x value of negative 1.8 all the way up to the x value of 0, I'm increasing. And then from 0 until I get to that x value of 1, I'm decreasing. And then from the x value of 1 right here all the way up, I am increasing. Okay. So the key calculator strokes. This is where you input the variable. Y equals is where you put the graph. Second trace accesses all the menus, a lot of the menus. Okay. And then you have the left bound and the right bound. So you're setting boundaries. Where do you want the calculator to find a value? Okay. Okay. And that is the basic beginning of the calculator.